Okay, so the session is now starting. If you head to the Slack channel, you'll see a link to the video. There's a thumbs up. If you just click on that, so that way I know that you're watching it, that'd be great. That's 2 thumbs up now. So just again, the session is starting. If you can, 5 likes, wonderful. The more thumbs up that appear there will just let me know that people are actually tuning in. We have 7 now. Let's see, where are the options? Details, here we go. 42 members, but only 7 likes. Okay. So at the very bottom, there's a thumbs up. If you, at the very bottom of the Slack channel, there's a thumbs up. If you press that thumb, then it'll just indicate to me that you're watching, and I'll be able to just hold off until a few more people show up. I don't want to start if people aren't aware that it's actually started. So the first question is, why have I only got the left channel working for my headset? That's probably because I'm looking to my left while I'm reading. When I'm actually facing my monitor, then it'll probably be centered. So for the majority of the time, it will be probably both channels, but sometimes you may experience a left channel only. Okay, so there are a few questions at the very top of this Slack channel. For those of you who aren't on the channel, I will read out the questions, and then we'll go ahead and answer them. So the very first question is by J. Arbin, and that asks about a sample question for which I believe is the exam in for the UNSW course Comp 6771. It's talking about a template class called vector, and the question is, ensure that the vector of t can only be instantiated if t is copy assignable and default constructible. Hint: static assert plus type traits. And so the question is essentially that the person doesn't know much about static assert or about how to check if a type is copy assignable. So for a type to be, to check a type to be copy assignable or default constructible, we'll need to include something called type traits, and we'll also need a template type name T. And so what we're going to do is, we're not really going to have very much in this class. It's just going to be default constructible vector of t, and what we're going to do is we're going to check that the type traits are, we're going to check this vector takes t that is default constructible and copy assignable. So the first thing that we're going to do is we're going to type in static assert, and we will but what we'll need to do is we'll need to use default, so is underscore default constructible t value, and then we'll put in quotes t is not default constructed. And so what this does is it will what we're going to do is we've got this thing called a type function. And what a type function is a function that takes a type and gives us back a value. And so what we're doing is we're passing in t as our parameter, and it will check to make sure that t has a default constructor. Is default constructible, it's a type function, and the value is what it returns. And if this returns false, then this static assert will fire, and the program will refuse to compile on the grounds of t is not default constructible. Similarly, we can static assert on is copy assignable. And this will do exactly the same thing. If there's no copy assignment operator for t, then this program won't compile. So now let's try and instantiate a vector of integers, and we'll go from there. So we'll call this one foo.cpp. All right, we'll try bar.cpp. Okay, let's cancel, close, don't save. And that fixes it. Okay. And where is it? So what we're going to do is we're going to change this one to bar and this one to bar.cpp. All right. So what we'll do is we'll try to build debug vector. Yes, I forgot my. All right, let's try that again. Task build debug vector, and so it compiles because int is both default constructible and copy assignable. Now let's create a type. That is not default constructible. Foo delete, and we'll try another one. If we build this one here, it fires this one here. It fires this static assert saying that t is not default constructible. And similarly, if we say foo operator equals const foo ref equals delete, and we try that again. Build debug vector. We get two static asserts fired this time because the type is neither default constructible nor is it copy assignable. So Javan, does that answer your question? Yes, Matt has commented, if you're not sure, go to CPP reference. That is an amazing site. It is the best reference material for C++ online. And it's a wiki. A lot of the contributors are people who actually contribute to the C++ standard as well. So they do know what they're talking about, and it's consistently up to date. All right, so we're going to move on to the next question, which is, how does this code work? So I'm going to copy this into, so the question is, how does the R value reference to an int a equals 1, a equals 2 work? Does it modify memory in the data segment? I think this is impossible, so there is probably some invisible memory allocated on the stack. Now, this is a red herring. there is no data segment in C++. That is a processor architecture thing. C++ doesn't have a notion of a data segment. It doesn't have a notion of a stack. There's actually no stack in C++. These things are implementation defined and are models in which we build computers on, not the programming language itself. So what we have here is an R value reference to some temporary object. And what we're doing is we're binding a reference to that object, which then allows us to modify it. So yes, there is some invisible object, which is called a temporary in C++. This here is going to be a value that we can't modify, but there will be an object that's been defined in order for us to bind it to the R value reference. Does anyone have any questions on that? Oop, my mouse is not playing ball. Okay, no questions on that one there. So the next question is regarding some code, I think from a tutorial. All right, let's quickly clean this up because I don't have clean tidy installed. Okay, so I know the name hiding happens in C++. Why is it happening like this? Why is there a difference using pointer of base class or derived class to access virtual functions? Why can we solve this by adding using fruit eat? So the problem is that when we let's get rid of that one there. All right, so if we compile this, yep, so that's fine because I have that. All right, let's try that again. Task, build debug vector. And that one should compile. Yep, wonderful. All right, and then if we run that, what is that? Let's control. So what it does is it prints out, let's change that to fruit so it looks pretty, and apple, new line, so it looks pretty. We'll rebuild. So it prints out fruit twice. That's with the using fruit eat, but if we get rid of that one there and we try that again, we have a W conversion. All right, let me quickly take that one out, and we will try that again. So what happened was I had a warning on that prevents you from doing floating point to integer conversion because that's a good idea. And if we rerun this, but it wasn't working for this one here. If we rerun this program, we get fruit and we get apple, despite the fact that we have a function overload here called eat that takes a float and we're passing in a float. Now I'll put that back on because that W conversion actually caught the problem. And so the question is why, I believe the question for this is asking why doesn't eat in apple call this one here. And the reason is because name hiding takes whatever's in here and it takes precedence over this one here. If we wanted to, avoid that, we need to say that we're going to be basically importing all the functions from fruit that have this, that share the same name into here, into apple. And I'm not exactly sure why that's the case. I believe it's just a design on the language's part to make sure that you aren't accidentally calling the wrong function. Now, there is a problem here, and that's that it's not terribly clear what's going on with these guys. So this does not override this function here. Just because it says virtual and it has the same name does not mean anything. This is a completely different overload. What we need to do is we need to get rid of that virtual and put override over here. Now that won't change anything. Just putting override on the other side does not change the fact that this doesn't override anything. The functions have two different signatures. But what this will do is it will catch the problem. So you never put virtual on the left-hand side of a function that is going to be overriding something from a base class. You put override on the right-hand side or final, and this will have essentially the same effects because it's, again, not overriding anything. This will let us know that we actually need to change it to build, and now when we run the program we have apple because they're both apples. However, another thing is that we shouldn't be putting this on the free store at all, and we don't need a pointer here. In fact, what we should be doing is using references. We have absolutely no reason to be using pointers whatsoever. Okay, so does that answer the question? If no one, if people do have questions about things that I've previously said and I've just been steamrolling on, please post them underneath and I'll get to them afterward. All right, so the next question is, why do we have perfect forwarding? What is a scenario where using T reference instead of const T reference, so reference to const? So the question is, when we're going to use T ref instead of const T ref outside of move assignment and move construction. And the case is right here. So type name T. Actually, I might go and be a little bit adventurous. And what I'll do is I will. So here is an example. So what we do is we have a T const int I. And so what we're going to do is we're going to return what's known as subscript implementation, pass in this. And then what we're going to do is we're also going to make that no accept, and then we can make this a reference as well. Const T, so reference to const operator const int I. No accept, return subscript implementation this, and private. So what we'll do is we'll have a unique pointer of T called data, and then we'll have type name V, And we're going to make a static function called subscript implementation. And it will take what's known as a forwarding reference to a type v, which will always be of some vector of t. And except on this side. And what we're going to do is we're going to say that it returns data. So I also need to put I here and I here. Okay, so what we're doing is we're taking the type of whatever the object is, which is denoted by star this, and we're handing it over to subscript implementation. And this implementation takes a forwarding reference to a type v. And what the forwarding reference does is it says, I can be any type. That's not an R value reference, that's any type at all. And so we're saying to the compiler, I don't know what the type is right now. So Matt has just said it should be v.data subscript. No, it needs to be v of I. So what we're doing is we're actually calling this function. Oh, right. Yes. Thanks, Matt. That gets me every time. So what we're doing is we're saying, I don't know to the compiler, I don't know what the type is right now. And there's some generic context, I would like you to deduce the type for me. And so it could be it could be an L value reference. It could be an L value reference to Const. It could be an L value reference to a volatile object. It could be an R value reference. It could be an R value reference to a constant object, which is ridiculous and you should never do that. And so it could be any of the permutations. And this doesn't cover the forwarding example. In order to cover the forwarding example, we'll need another one for void pushback const t v, and so we'll have pushback implementation star this and v, and then we'll have void pushback t, and this one takes a v, and so we'll have pushback implementation of star this, and then we'll move v. And in our pushback implementation, it's going to resemble very much what we have up there. Type name f. So in this case, it's not going to be a static function because we're not deducing a return type. We're actually going to be forwarding a type to this. So we say f, and I should probably add a t star end, which equals, we'll not worry about what t end is for now. We'll just pretend that it's going to work because I'm not going to compile this. What we do is we say data, sorry, not data, we say start end equals step forward f of f. And so, and then we say plus end. What's happening here is on this side, we are saying to the compiler, if this is an R value reference, it needs to be moved. If it's not an R value reference, it's going to be copied. That's essentially the way that forward works. It means it's like a conditional move. If it's an R value reference, call move. If it's not, then proceed as normal. And it doesn't mean you start throwing forward everywhere, but in a case where you do have a forwarding reference, this is where you use it. Now, the difference between this trefref and this frefref is very subtle, but it is very different. So here we have an R value reference because the T is known whenever we call a pushback. It's deduced to be the same as the vector of T. We can never call pushback when T is not known. However, pushback implementation is a template function, which means that we don't know the type when we're writing the function. What f is deduced as is determined by the functions that call it, and in this case, v is going to be a reference to const, and in this case, v is an R value reference. So it's this type name, template type name f, that makes all the difference, that separates this from being this from this, and what makes trefref an R value reference and frefref a forwarding reference. Now, I'm just going to scroll to the bottom of the Slack channel to see if there are any more questions. Okay, so it looks like a few people are typing. So what's the easiest way to implement a Const iterator? I'll come back to that one. Let's head back to the top. So the next question is, how do we use type traits to ensure that functions can only be instantiated for specific types? Or do we just check the types in the template function and throw an exception if it's not the type we want? No, please don't do that. Matthew Phillips has asked, and the pushback implementation gets created more than once if it is called with, say, an R value and an L value. So yes, if we pass in not an R value and an L value, it's an R value reference and an L value reference. And the answer to that is yes. If we pass in two different things, it will, two different types, then it will deduce two different types. Now, so the question on deducing types, I can actually make that work for this one here. And so what we're going to do is we're going to say that we have a special constructor. So we have a vector that takes in a t, just a regular t, and we're going to have what's called enable if underscore t, and then we're going to say is same v int t equals 0. And I am actually wrong in saying that. It should be template type name u equals t, enable if t equals 0, and then we have a u here, and we do some fancy stuff. And otherwise we have a vector of t, so template type name u equals t, stood enable if t not stood is same v int t 0 UU Alright, so what we're doing is we're using this thing called enable if t, and that is found in the type traits header. And what it will do is, so what we're going to do is we are saying that the constructor only exists if the t that we're passing in is going to be an integer. So if it's an integer, this function exists to the compiler. If it's not an integer, the highlighted function does not exist, and the non-highlighted constructor does exist. And the way this works is due to something called SFINAE. And SFINAE stands for substitution failure is not an error. That means that if we fail to substitute a type in to a template function or a class, then what's going to happen is questions are going in. I got a bit distracted. So what happens is if you can't substitute the type, then it just moves on to the next specialization and tries to do it there until it runs out of possible candidates. And so in this case, I should probably I hope this will compile. Build the bug vector. No, it won't. Is saying V is not a member of namespace standard because we're using C++ 14. And that's a C++ 17 feature. Task build debug vector. Unique pointer doesn't exist because it's in memory. This is why having an IDE would be very nice. So let's get rid of this. Build. And we're on line 17. Yes, okay. So. Okay, so it compiles. What we'll do is we will print out one here, and we will also print out something here. And then we will proceed to create a vector of int and a vector of double. And watch it fail mirror spectacularly. How did I know that was going to happen? No type in enable if on line 15. Okay. Right, before we do that, let's just quickly turn you off. Find out what you're complaining about. So what's happening is this constructor is failing. Okay, so I know what's happening here. Essentially, I'm not going to continue on with this for now. Let me mull on this one for a bit and I'll come back to it. Okay, so Gary has asked, can we go through the key ideas of multi-threading? What would you take into account when you write threaded code? And the answer to this can't be filled in this session. That is a lot of, there's a lot of material to go through that. The best that I can suggest for now is to read Anthony Williams' book. It's C++ Concurrency in Action. The second edition has just released, and it's a very good book. I have read it, and I cannot condense that down into, say, 10 or 15 minutes of talking. If I need to consult something on threading, the two places that I go to are Anthony's book and CPP reference, because those two sites are the book and the site are the most reputable sources for this topic. And even when I wasn't using threading for C++, this book actually helped me out quite a fair bit, because it doesn't just cover threads and concurrency in C++, it covers a lot of the theory as well and how to model programs. So I have been able to use that book to write threader programs in other languages as well. In fact, there was a course that wasn't C++ based that I took, and it was only because of his first edition that I passed a particular assignment. So the next question is, could you please answer the question in the context of assignment 3, the parallel bucket sort? How would you have thought about each of the aspects of dividing up work, synchronization, and managing threads? Again, that's something that I can't answer in this session, but Anthony's book will cover all the answers to that question. Okay, and the next question is, could you talk about template metaprogramming in real use? Our example in slides and Googling are all a bit contrived. All right, so yes, the internet has a lot of very poorly written template metaprogramming code. I do have a program that relies heavily on very advanced template metaprogramming where I work. There is a lot of template metaprogramming. In fact, all C++ code bases that I've worked on use some amount of template metaprogramming. And this is an example of template metaprogramming. It may not be working, but what we're doing is we're using templates to have things work at compile time. This is a template function. So it's a function that's evaluated at compile time, and it's inside this, and we use this to determine which functions are going to be called. So let me open up this vector.cpp, which I know compiles and mostly works. See if there's any template metaprogramming in this one here. Ah, yes, okay. So this here is is something that relies on template metaprogramming. And the way this works is, what I'm doing is I'm saying that if we pass in a non-integral to the next power of 2, we won't compile. So let's go down here and try calling next power of 2 with 3.14. We'll save that, and we'll go change this to vector task build. And so what's happening is we're getting an error because, well, actually we're getting a couple of errors. Static assert is another form of template metaprogramming. The one that I'm talking about here says that there's no matching function call to next power of 2 that takes a double. And the reason for that, it doesn't explain it at all in the diagnostic that we get back. But the reason is because we're using this thing called enable if. And so what's happening is it can't deduce that enable if, and so it refuses to compile the function. This is essentially the basis of what we call constraint-based generic programming. And a lot of template metaprogramming is based around constraining functions to take certain types and constraining data structures and giving them specialized values. That's all template metaprogramming. You'll actually find that a lot of the standard library is based on template metaprogramming. Now, you may not see that just by reading the documentation or by reading even the what's laid out in the standard, but if you take a look at implementation, you'll notice that there is going to be a significant amount of template metaprogramming in modern day C++. And that's not necessarily a good thing. I mean, for example, if you take a look at what's going on here, we're saying that the only candidate for a next power of 2 is something that takes a type t and a type enable if is integral of t, and then goes on to talk about this thing called concept requires, which I've put here. And that's not really telling you what the problem is when it refuses to compile. All it's saying is that it couldn't compile. So you need to understand template metaprogramming when you are going to be using it. And we are working on ways to fix that. I'm not going to talk about them right now unless anyone directly mentions them. But using template metaprogramming is essentially a necessary evil. It's not the best thing in the world, but because it gets us to do things at compile time, and having things happen at compile time are always better than having things fail at compile time is always better than having things fail at runtime, because you, the programmer, can see what's going on and you need to deal with the problem directly, rather than having a user find the problem 6 months down the track when making a bug fix might be quite costly, and you'll have to roll it out to everyone and get everyone to update. If it's happening in your code, you need to deal with it then and there. On the same token, the code now looks less than ideal. There are ways we can clean it up. One way of doing that was that I added this macro, which makes the code easy to read, because I'm saying that there is a concept that requires this is integral boolean, but when we get the diagnostic back, it then looks even worse than if we just put this in there. So if I put this, get rid of this p task build debug vector, you'll notice that it's slightly cleaner, but it's not much better. And what this does is it makes things a little bit harder on the programmer at compile time, but anyone that uses that function will have a much nicer time with the function. If you can avoid template metaprogramming in favor of metaprogramming, that's better. So template metaprogramming is a specialized form of metaprogramming. Metaprogramming can also come in the form of using constant expressions. Now, you should make as many functions as you can constant expressions. There is a video, there's a conference talk given by Jason Turner and Ben Dean at both C++ Now and CPPCon, in both of which were hosted in 2017. You can find them on YouTube. It's called Const Expert All the Things. And this is one of, I'd say if you're interested in metaprogramming, it's something that you definitely need to watch, because it takes regular C++ code and executes it at compile time. So this here, this next power of 2, that operates at compile time, and it may not operate at compile time. I actually use it in most cases not to work at compile time but at runtime, and that's fine. The function still works at runtime, but I've given the compiler the opportunity to decide, hey, do I want this to be evaluated at compile time? And I've given programmers the opportunity to say, yes, I definitely want this to be executed at compile time, because I can now say foo equals the next power of 2 for 1, 2, 3, 4, 5. And so what this will do is, because I've said that foo is a constant expression, foo will, so next power of 2 will be computed at compile time. But if I'd removed this and just done this, then it wouldn't be possible to compile this, because foo needs to be at best a const object. Now, shortly after I got into teaching C++, I made a diagram explaining whether or not you should make something a constant expression, whether or not you should make it a constant object, or whether or not you should make it a mutable object. And if you can make something a constant expression, always make it a constant expression. Do not make it a non-constant expression, because then it's guaranteed to be an expression that can be used at compile time. If you don't have that opportunity, if you need to rely on the runtime for whatever reason, and a lot of things will need to depend on the runtime, make it a constant object, unless you need to modify it, and that's an absolute need, in which case make it a mutable object. But try to keep everything as immutable as possible. Alright, so I've spent quite a bit of time explaining metaprogramming in general. I'm going to move on to the next one. And that's, could you give a sketch on how you would do assignment 3 in a lock-free way? And again, the answer to that is no. I'm going to defer that to Anthony Williams' textbook, because he covers how to do that sort of thing in a much better way than I could ever possibly explain that. The next question is, in object-oriented programming, are the Gang of 4 and other design patterns still relevant today? And the answer to that is yes. Design patterns transcend C++. They are not relevant to the language. They are a way to implement things. And because they're not relevant to the language, but relevant to how you use the language, that doesn't really matter, because you can implement them using other languages such as C# or Java. If you are really, really, really determined, you might even be able to do it in C. They're really just ways to ensure that you're programming in some sort of quote standardized unquote way. It's not a standard way of programming, but design patterns are supposed to be something that you can take and people will understand elsewhere. The code in Gang of 4 in their book is incredibly outdated. It predates standard C++, so rather than looking at the code, I would focus on the theory and attempt to re-implement that sort of stuff using modern C++. There are a few patterns in there that will be out of date, such as the visitor pattern in C++ 17. We can improve upon that using certain objects such as standard variant, but the idea behind the visitor pattern is still the same. It's just the way in which we implement it that changes. So the answer is not quite yes, it's not quite no actually. The theory is still relevant, the implementation will definitely have changed. Alright, so moving down, we have just a few things about technical difficulties from the start. Okay, so I think Matt's answered that one. All right. So the next question is, if I miss a question, please repost it, and I will target it again. So the next question is, and pushback implementation gets called more than once if it is called with an elevator. I've already answered that question. Okay, so Eric likes C++ has asked, I have found that pushback is much slower than the subscript operator or .at in assignment 5, and they are all much slower than dealing with standard array or raw arrays. How can I choose them when I should deal with programs that require high performance, like assignment 5? The default container that you use is vector. There is no there is no other type that you use first. If you know the size of an array at compile time, that's great. Use vector. If you want to reserve some memory ahead of time, you can go for it. You can do that. You still use vector. Vector is your default type. You only use standard array when you absolutely cannot afford to do dynamic memory allocation, and you know the size at at compile time, and you have measured for performance to say that vector is not scaling with respect to a compile time array. Vector is always going to be the first choice that you need to make. And if I see any type other than a vector, the first thing I'm going to do is ask, why are you not using vector? And I actually do that in code reviews. I will ask, why isn't this vector? In certain situations, such as code that goes onto a GPU, you can't have dynamic memory allocation, which means that vector is out of the running. You need to use a compile time type. So an object that allocates memory at compile time. So standard array is what we need to use, but that's a very special case. As Matt has pointed out on Slack, the subscript operator for both array and vector are going to be equal. There is not going to be a performance difference, and that's correct. But for pushback, a reason that pushback may or may not be slower than when you're using subscript is because there may be a dynamic memory allocation. You may need to reallocate and then move all the objects from the current point of storage to the new point of storage and then add the next object. So there's an amortized constant pushback, insertion, but you should always be using pushback to add new elements unless you already have something reserved, because that is essentially the way that programmers expect it to be done, and that's the way in which it's recommended, because you'll find that vector is optimized for that sort of situation. But before we start talking performance, you always need to profile. If you're looking for a speed boost, you need to be timing your programs. If you're looking for a memory boost, then you are going to need to be measuring memory. You can't just say, well, an array allocates at compile time, whereas a vector does it at runtime. No, that's not enough, because if you haven't benchmarked, you don't know that that's the case. Chandler Carath said at CPCon this year, if you don't measure performance, you don't care about the performance of that code. You do not care about performance unless you benchmark, I believe is actually what he said. That's correct. If you haven't benchmarked your code, then don't start talking performance because you don't know how well that code performs. All right, so the next question is, what's the benefit of static assert versus enable if? For example, checking for integral, what is the benefit of what you had for next power versus a static assert? Now, the reason that I chose to use the reason I chose to use enable if over static assert is because that means that the function doesn't exist when I go to use the it without using an integer. If I put a static assert in, then what's happening is I'm actually doing something inside the function that's part of the implementation. This is quasi-implementation specific, but it's much more a part of the declaration. So it's a part of the declaration, not a part of the implementation, which means that it's a part of the interface, which means that this is the section that the user is concerned about. If this were to be documented, it would be a part of the documented interface. This would be what you would see in some documentation that I would write. That is why I prefer using enable if t over using over a static assert. I very rarely use static asserts, but I also typically have other tools at my disposal that the course doesn't have that makes my constraint-based generic programming much simpler. Okay, so the next question is, how smart is Const Explorer? What are the limits of things that can be evaluated at compile time? Const Explorer these days is extremely powerful. In C++ 11, it was quite limited. In C++ 14, it got a huge boost, which has allowed this function to exist. This is not valid C++ 11 code. In C++ 17, it became even more powerful. We now have what's known as an if Const Explorer. Or Const Explorer if. So if Const Explorer. So for technical reasons, the code reads if Const Explorer, but we call that Const Explorer if. The reason that I say it the other way around is because it was introduced to me as if Const Explorer. Some value. So what's going to happen here in this block is if that some value returns evaluates to false, then things is never even compiled. So that's incredibly powerful because what I can do is I can have a t here, tt, and I can say if t is an integer of vectors, then I can say v.reserve 100 integers. Because a vector is the only container that takes that has a reserve function, that won't work for any other container. But what's happening is I'm checking to see if it's a vector ahead of time. And this allows me to reduce the number of specializations that I need to make. Because previously what I would need to do is I would need to have a specialized structure that would do that for me, and it makes the code look very ugly. And you don't start abandoning specializations in favor of if Const Explorer. What you do is you take little bits that would otherwise force you to make an entirely new specialization just for that one small segment, and you wrap that inside the Const Explorer if. But that's not relevant to the course. That's just talking about how constant expressions have been evolving. We also now have constant expressions for lambdas, which is great. One thing that I would like to see happen in C++ 20 is that we get constant expression operator new and operator delete. That will mean that we can have compile time vectors, which would make my life a lot easier. And a lot of programs, while the compile times would be incredibly slow, they would be boosted immensely in the sense that that at runtime a lot of computation won't actually be happening. But again, that's neither here nor there for now. All right, so the next question is, sure, in what cases does this make a big difference, other than if doing overloading? I'm not sure what Adrian means there, so I will come back to that one. Adrian, could you please just elaborate a little bit more on what you mean by that? The next question is, could you please recommend that? Okay, yep, Matt's answered that one. Okay, so the next question is when to use when to use function overloading versus template specialization. Always prefer overloading. Always. The only time that you should ever use a template specialization just is when you don't actually have something that needs to be deduced. You need to specify it. For example, make unique is something where we need to provide the specialization because we don't know what the T is if we're just passing in an arbitrary number of arguments. And if T is going to be an array, because there are two types of make unique. There's so make unique. I'll bring this up. So what we have is we have a make unique that takes a T, and make unique that takes a T for an array type with an unknown bound. If we head down here, what we do is we have a make unique like so and like so. This needs to be an explicit specialization that can't be done using function overloading, at least not to my knowledge. All right, so we've reached the end of the questions on Slack at the moment, but I can see that someone's typing. So I'm just going to wait for that. Okay, so the next question is, can I recommend some profiling tools? Tools that I use for profiling are variants of Valgrind, address sanitizer, undefined behavior sanitizer, thread sanitizer, and I don't think I've ever used leak sanitizer. So the way in which we use asan, ubsan, and tsan, we say things like this. So this is a JSON file that talks about how to build a program using GCC. The args are just provided in a list format for reasons that I'm not terribly, I don't really care about why that is the case. I've never really looked into why. But just each argument is going to be on a separate line. So if you're doing this on the command line, you just provide it all as one thing. So if I want to sanitize equals, so if I want to be profiling on addresses, then I will use this, and it will help me catch a bunch of things. If I want to profile for undefined behavior, then I will use fsanitize undefined. My debug builds contain both of these. In fact, you should probably, I'm actually debating whether or not to keep this one in production I haven't tested it out yet, but if I put that in release, then it will force a crash rather than invoking undefined behavior, which is always better. And sanitize equals thread. And so what these will do is this one will do turn on asan, this one will turn on ubsan, and this one will turn on tsan. And these are the ones that I use by default. If I find that they're not working for me, then I will use Valgrind, which isn't just a profiler, it's much more powerful. But I find that Callgrind, Memcheck, and CacheGrind are the ones that I use the most often. If I want to time things, then it depends on the granularity and how much trouble I want to go to. But don't really care about actually, if I don't care about it enough to set up some serious tests, then I will just write my own time function, which I can do pretty quickly now that I have memorized it, and I will just do a quick dummy program and rely on my own thing. But if I actually want to, if I seriously do care about the performance and I'm not just going, oh, I wonder how this behaves, then I'll use Google Benchmark. It's currently one of the better ones. I do think that the Catch 2 test framework is going to eventually have some benchmarking, but at the moment it doesn't. So it's best if you stick with Google Benchmark for now. But if you want to be doing testing, unit testing, and you should absolutely be doing unit testing, rather than rolling your own unit testing, I strongly recommend using something such as Catch or a different test framework. You should absolutely learn how to write unit tests properly. They will make your life a lot easier. Something that I've started to do is to model my tests mathematically. For example, a course that I gave in the US recently, it had an implementation of vector that was part of the class, and the class, the tests were very mathematically oriented. So something that I did was I made a point of checking the vectors' equality was reflexive, symmetric, and transitive, because those are properties of equivalence relations, and I was guaranteeing that equality meant equivalence. Now, Matthew asks, what do you do to quickly find the bottleneck in a program? Quickly finding a bottleneck in a program is not a thing. You can't quickly find a bottleneck. You need to sit down and analyze what is happening. In order to do that, I would be benchmarking. Or calling CacheGrind if I wanted to narrow it down. So, CacheGrind? Callgrind. I think it's Callgrind actually. Callgrind sounds... I'm just going to quickly look that up. There's actually an ACCU article or video. There's an ACCU journal on Valgrind, so I'll put that in here. You might like to read that. So Callgrind is based on CacheGrind. I think one contains the other, but I'm not 100% sure, which is why I'm... so Callgrind is similar to CacheGrind. I haven't used this in quite a while, but what this will do is it will essentially let you work out which functions are taking the longest. Of course, your program is going to take forever to run, but that's not a problem when you're trying to find a bottleneck. You need to sit down and actually do that. So the next question is, okay, so Eric has asked a question that I cannot answer. All right, so there are no more questions at present. Oh, someone's typing. No? Okay. So there are no more questions at present. I'm going to hang around for another couple of minutes just to see if anyone else is thinking of a question or is typing it up and experimenting. But I think I'll wrap up at 25 past. So it's a little bit more than 5 minutes, but it'll just give people a bit of time to get some questions out. If there are no more questions, then I'll wrap up at 25 past. If there are more questions, then I'll continue to answer. Okay, so we have a new question, and the question is, what does this mean? So could I ask what this means? In the lecture we have this. And that won't compile. The reason for that is because what we have here is an enable if t that's taking a boolean, and that's it. It's not providing a type to deduce. So what you need to do is you need to provide some type here, and then this will be fine. So does that answer your question? Okay, so Matt has just noted that the default type is void. I was not aware of that. That will actually change the way in which I use it. Okay. All right, that's cool. All right, so apparently you can have no type, but you still need to have the. All right, so I'm not entirely sure what the question is then. Would you be able to provide a little bit more clarification, please? Okay, so Johnson has. I'll come back to Shenlong's question. But Johnson, Matt looks like he's answered it. Thanks, Matt. Johnson has asked earlier. Someone asked if there is an easier way to implement a const iterator for a custom iterator. Not sure if this was answered already. So answering that question really is really determined by how you implement your iterator. Sorry, not how you implement your iterator. How you implement your structure. So I assume this is with respect to the assignment that that you guys had to do. I can say yes, there is an easier way to implement that than having two separate classes, but it's not necessarily something that you might find to be trivial when you first start out. If I were to be recommending something, then I would say that you would want to have something such as vector iterator t. So using iterator equals vector iterator, and using const iterator equals vector iterator of const t. That's the way that I will do it. But again, that really comes down to how you implement your container in order to implement that. Of course, if you can implement something using a vector or a map, then you'll want to then that will determine what's going on there. So does that answer the question? Okay, I understand what Shenlong's asking about now. And yes, I did make a classic mistake there. So essentially what Shenlong has pointed out is that all I have done with these guys is that I've essentially got the same thing working with different types. So what I really might try is this. All right. I will answer that one offline now because that one's been a bit plaguing. Are there any further questions? Yes, Matt, that's correct. I just can't seem to remember how to do it off the top of my head. Okay. Well, that will hopefully work. But it's not the route that I was actually going for. No? Okay. I'm going to leave that one there for now. Because there is a 13-second latency and oh, right, I see what you mean. So we have a help function. Okay, so there is a way to actually do this. It just seems to have slipped my mind. Concept requires. Where's the real concept requires? Let's bring you over here. Projects. Is range v3 ever? Or is it still my backup? Okay. Utility, perhaps? Concept, here we go. Okay. So, oh, that's what he does. Okay. All right. So the way that this this is done is exactly the same, it seems. So I'm going to leave this question here for now. I'll get back to you on that one offline. It seems like it'll be the easiest way for me to handle that. We can have a chat about that in a little bit. All right, so I'll hang around till 11:35, but thanks for coming. And I wish you all the best of luck with the exam. If you're interested in working on C++ some more, or you are wondering about what you can do with C++ in the real world, I'm also happy to talk about that. It's always a fun topic for me to talk about. Thanks, Matt. Okay, so another question is, why can I say type equals 0 in an enable if t? So why am I allowed to do this, or specifically this? The reason is because what I'm saying is that I have a type, and you can do this inside a template. So I can say int equals 0, which is effectively what I'm saying, except that I'm providing a condition on that. It needs to exist. So Matthew has asked, is there any noticeable difference when using Emplace back versus pushback for trivial things like ints? The answer to that is no. Emplace back is only advantageous over a pushback when you want to directly construct something and inside the vector. There won't be any difference for the two because int, so something that's a fundamental type is not going to, it's essentially just going to be the same thing, because if you whether or not you're constructing it or copying it, it's going to be identical. Essentially it's still just going to be a construction. But I try to use Emplace back unless I know I'm going to be performing a copy or a move. And even then, I could still technically use Emplace back. It's just that I do use Emplace back to say I am constructing something, and push back to say I am copying and or I am moving. Alright, so I will carry this over to 11:40, and if there are no further questions at 11:40, I will I'll wrap things up. But if questions continue to flow, then I will stop at midday. Could I really have been that silly? No, it seems that as a general rule, if you had objects that were kind of large, would we recommend to store pointers to those objects rather than placing objects themselves? No, absolutely not. I would like to see the talk itself before. So Matthew has asked, I seem to remember a talk saying that it improves cache hits or something. That would depend on what you're doing with the data, but I would really like to see the talk on that, because as Matt has said, the opposite is something that I would have thought as well. Because if you have a pointer to an object, then you're now having to go through that pointer to get to another point in memory, whereas if you have it there directly, then you're working on the object. Oh, that's why it's failing me out. Okay. So let's put in. Actually, let's delete these guys, because I do actually want that to be a default constructor. All right. Hooray! It works. Okay. So if anyone is still here, the reason in which this constructor failed to compile is because I was doing the very thing that I was trying to explain that you avoid. So to repeat that, I was trying to explain something that you need to do in order to use enable if in this particular context, and then proceeded to do the exact thing that I was saying you should not do. This is where we cue the applause and whatnot for my stupidity. So essentially what was happening was that I was basically doing this. You can forget about the U for now, because what I was doing was this. And this is what we call a non-dependent context. So Shenlong, if you're still here, this is directly relevant to what you were asking before, as well as the person who asked about enable if, about determining types at compile time versus runtime. This is going to be directly relevant to you as well. So what we have here is, pardon me, what we have here is a dependent context, because we know what T is when we call vector. Sorry, non-dependent. And so whenever we call a constructor, we already know what T is, because in order to call the constructor, we actually need to know what T is. And that goes back to the whole, when we were talking about forwarding references versus R-value references at the very end of the forwarding references section, how I said that pushback, so how I said that this T is an R-value reference, whereas this F is a forwarding reference, simply because in this context we do know what T is. It's always going to be the type of the vector, the value type of the vector, whereas here we have a forwarding reference because we have a template parameter and we don't know what F is at this point in definition. Similarly, up here what we have is a function where we know what T is. So this can be done at the first phase of lookup. So essentially what happens is the vector is deduced, and then it just goes and fills in all the T's, and then it evaluates this is same, and that turns out to be true, and this one turns out to be false. And because this one's false, this template isn't covered under the rules of SFINAE, because we already know what the T is. So what we need to do is we need to add a second type called U and put that here, and then what that will do is, now we don't know what U is. We're saying that U is by default going to be T, but it could change. The compiler now no longer knows what T is. Not what T is, what U is. And so everything is dependent on U. And even though we are technically hinging on the fact that U is going to be T, we don't know that. Now, if you wanted to be absolutely sure that, that U and T were identical, then you can do this. So what I do is I change this to the concept requires, and I say standard is same TU value, and then I can get rid of this. And then what I'll do is I'll take this and I'll put this down here. That was a bit jarring, and I can get rid of this bit here and just do that. And so now what we're saying is that even though we don't know what U is at compile time, we do know that what's happening is we're saying to the compiler this is a dependent type, but then in our concept check, when we're constraining our actual check, what we're saying is if T and U aren't the same value, refuse to compile, because that doesn't make sense. And so then if we have some sneaky programmer that worked out a way to get around that, well, we've caught them up. So if we now add this one back into the mix, it should compile. Pass 3 arguments. Oh, okay, yep, I know what the problem is there. So this one needs to be implementation, and we have define this is some serious macro magic that you shouldn't be doing if you can avoid it. If this doesn't work, then I will just go back to the enable if version. Alright, so what I'm going to do is I'm going to just go back to the enable if version. And I will uncomment this one here. And in answer to Matthew's question, I will need to rewatch that video to pinpoint exactly. Oh, I see what you mean. Yeah, so if Chandler's saying that, then there's a high chance that it's correct. When I say high chance, I mean except in some really small case that you've been working on for years. Like Chandler knows what he's talking about. I would say that comes down, I need to look at the context in which he's talking about in order to understand what he's talking about. Okay, so that works. And if we do this, so it says int and not int. All right, so I'm glad I put that to bed because that was very annoying. Now the concept requires wasn't working as I would have liked. I've overlooked something there, but that's okay. In the exam, don't use concept requires because you're probably not going to have time to sit there and debug a macro that you learnt about from someone online. I would recommend just sticking with enable if t. It looks ugly, yes. I do not think that if you need, if the question is saying that you need to constrain your types, then you will, Matt will need to confirm this, but I do not expect that will impact any marks. And if it does, then there will most likely be a secondary reason as well. And that little bit is just so that way I'm not putting Matt in an awkward position. So Matt has just said the only thing that will matter is the actual code, or the functionality of the code, which is great. So just for now, stick with enable if t, and I can point you in the direction of getting things better than enable if t for non-comp 6771 code. You definitely won't be able to do this in the course, but outside of the course, there are ways to make this even better. And of course, as Matt has pointed out on Slack, there is also static assert. So if you're finding things aren't working using enable if, try using static assert as well. Matt's pointed out that static assert during an exam might be faster and easier, and I'm not going to disagree there. You just saw me messing around with dependent types, and that took quite a fair portion of this time, and it was all because I just got the wrong type in the wrong spot. So a static assert may be better, but that the reason that I've been using enable if more so than static assert is because that's what I prefer. And understanding enable if will help if you are going to be going to a company that relies on template metaprogramming. You'll find that a lot of their code does have enable if as it switches. If you're looking at some incredibly older code bases, you may even find it says boost enable if. That's because this came out of the Boost programming library, the template metaprogramming library to be exact. I have worked on a code base that can't use standard enable if. I no longer with this company, but they need to use Boost enable if because the code is so old. Alright, so there are no more questions. I'm going to stay on until 11:55, and if any more questions come between now and then, I will answer them. Otherwise, I will hit the off button at 11:55. Alright, it's 11:55, so I'm going to wrap things up now. Thank you for watching, and I'll see you in the Facebook group.